Welcome to qnawire.
So this is a problem of a parallel plate capacitor. So we are given that the capacitance of a parallel plate capacitor is equal to, let's say, capacitance C for a parallel plate capacitor. It is equal to 920 picofarad, and the charge on each of the plates is given to be 3.9 microcoulomb. So this information is given to us. In the first part of the problem, we are being asked to find the potential difference between the plates. So for the first part of the problem, since the charge and the capacitance of the parallel plate is given to us, so the potential difference between the plates V is given by Q over C. So our charge is 3.9 times 10 raised to negative 6, and the capacitance is 920 picofarad, 10 raised to negative 12. And if we calculate this value, the charge comes out to be 4239.13 volt. So this is the value of the potential difference between the parallel plates of this parallel plate capacitor. That's the answer for the first part of the problem. Moving on to the second part, part B. So for part B, we are being asked if the charge is kept constant. So if the charge Q is kept constant and the separation between the plates is doubled, then we need to find the new capacitance C. So if the charge is kept constant, then what will be the value of the potential difference if the plate separation is doubled? So we need to find the new potential difference when the plate separation is doubled, keeping the charge constant. So as we know, for parallel plate capacitor, the capacitance C is given by this formula. So C equals epsilon naught electric permittivity, epsilon naught A over D, where A is the area of the plate and D is the plate separation. So C equals epsilon naught A over D. That's the capacitance for a parallel plate capacitor. Now it's given that keeping the charge constant, the plate separation is doubled. So the new capacitance, let's say C prime, is going to be equal to epsilon naught, area of the plate is constant, the separation is doubled, so it's 2D. So the new capacitance, as you can see, is half of the initial capacitance. So initial capacitance is C, and the new capacitance, which is C prime, is half of the initial capacitance. And since potential, so the new potential is going to be equal to Q, since capital charge is constant, divided by the new capacitance. And if I put the value of the new capacitance here, so it will be 2Q over C, which is nothing but equal to 2 times the value of the initial voltage. The potential difference, initial potential difference is V, and the new potential difference when the plate separation is doubled, keeping the charge constant, which is V prime, as we can see, is twice the initial potential difference. So it's 2 times V. And this value, V prime, the new potential difference, comes out to be, we just multiply 2 with the initial potential difference, which comes out to be 8,478.26 volt. So this is the value of the new potential difference when the plate separation is doubled, keeping charge Q constant. This is the answer for the second part of the problem. And in the third part, we are being asked to find the work which is required to double the separation. So the work required to make the separation between the plates twice of its initial separation. So the work required will be change in the potential energy. So the initial potential energy when there was no plate separation, like the plate separation is T, initial plate separation. So for capacitors, the potential energy is given by Q square over 2C. That's the formula for the potential energy. So the initial potential energy, the initial charge, which is given to be 3.9 microcoulomb times 10 raised to negative 6 whole square divided by 2 times the initial capacitance of this parallel capacitor, which is given to be 920 picofarad. And if you calculate that, the initial potential energy comes out to be 8.27 times 10 raised to negative 3 joules. And the final potential energy after the plate separation is doubled, that is the plate separation has become 2D instead of D. So in that case, since the charge is kept constant, so we have Q square here divided by 2 times the new capacitance, which we calculated here, C prime. So as you can see, C prime is half of the initial capacitance. So if I write C prime as C by 2, so I'm going to have Q square over C, which is nothing but equal to twice of the initial potential energy. So the final potential energy is twice of the initial potential energy. And the work done is nothing but change in the potential energy. Final minus initial. So final is twice of the initial minus the initial, which is nothing but equal to the initial potential energy. So the work done in our case equals 8.27 times 10 raised to negative 3 joules. So this is the work done to make the plate separation twice or 2D by keeping charge constant. This is the value for answer for the part C of the problem.